Hello everyone, my name is Anshu. I'm teaching in Electrical Engineering Department in GEMS Engineering College, Greater Noida. And today I'll be teaching you control systems. So I'll be starting with basics of control system. So when we are talking about control system, the most important thing comes in the mind is what is a system? A system processes inputs to produce output. A system is a combination of elements of one or more signal to accomplish a function and produce some output. So a system, if we give any input signal, the output signal will receive from a system. So we have studied various type of system: causal, anti-causal system, linear, non-linear, time variant, invariant, stable, unstable, static, dynamic, invertible and inverse system. Next is why control systems are required. The most important thing is that whenever we require a desired output, then only we require a control system so as to get the output that we desire. So control system has played a vital role in advance of engineering and science, and it is more important in space vehicles, missile guidance, robotics, modern manufacturing and industrial process. For example, the numerous control of machine tool in manufacturing industries, design of an autopilot system in the aerospace industries, designs of cars and trucks in automobiles industries, the speed governing system. Everywhere we require control system. It is also essential in the industrial operations as controlling pressure, temperature, humidity, viscosity, and flow in the process industry so as to control not only these factors but any external disturbances. These control systems plays a vital role. Controls helps in attaining optimal performance of dynamic system, improving productivity, relieving the stress of many routine repetitive manual operations. So what is a control system? Simply we can say, if we give any desired input to the same system and in the output if we receive the actual response, that is the simplified definition of a control system. So coming to the important terminology that we use in control system, what is a control system? Control system is an arrangement or a combination of various physical components, also called subsystems, connected in such a manner so as to attain a certain objective. So input is nothing but the excitation that we apply to the system. So to attain a output is called a input signal. Now output is the actual signal that we attain from the system is the output signal. The control action is nothing but is a quantity responsible for activating the system. So coming to open loop control system, our control system is classified as open loop control system and closed loop control system. So open loop system is a system in which the control action is independent of the output of the system is called as a open loop system. In open loop system, we don't have any feedback. So the example of open loop system are electric hand dryer. Suppose let's take an example of electric hand dryer. The electric hand dryer we see in various malls. So in that case, there is a light in that hand dryer. That light is called photovoltaic light. So in that light, if we put our hand in that machine, whenever the light flow is interrupted, then only the dryer will get activate and it will blow hot air towards your hand. So why that hand dryer is a open loop control system is because whether your hands are dried or they are wet, whenever you put your hands inside that machine, all you get is your, it will run for a particular period of time. So no matter whether your hands are totally dry or still they are wet, but it will run a cycle, complete cycle of say 30 seconds or 20 seconds, and then afterward it stops. So why we are considering that machine as an open loop system? Suppose if I put my wet hand in that machine, or I put my dry hand in that machine, whenever that light flow is interrupted, the machine will run for that duration of time. So we can say that that machine is an open loop system. So next is your bread toaster. Similarly, suppose if we have a bread toaster at our homes, we all use your bread pop-ups in our home in during our breakfast mostly. So whether you put a bread and you set a particular time period of 2 minutes, so whether your bread is burnt or it is properly roasted, the time it will complete a duration of that 2 minutes and afterward it will stop. So this is a kind of an open loop control system, in that the control action is independent of output, whether your output will be burnt bread or your output will be a not properly roasted bread. It will run for a particular duration of time and afterward it will stop. So automatic washing machine is another example of open loop control system. In automatic washing machine, we give dirty clothes as an input and output is your clean clothes. So in automatic washing machine, we put a certain time period. So we put a time, we set a timer say at for 20 minutes. So after 20 minutes, whether your clothes are still dirty or whether they are clean, it will run for 20 minutes only. If you put all the clean clothes in machine and if you start a timer, so in that case there is no sensor in order to detect whether the clothes are dirty or they are clean. It will completes its cycle that the input we have given. So that's why it's another example of open loop control system. So the advantage of open loop control system are it is simple in construction and design, because we have a input, desired input, a system, and output. Next is it is economical. It's uh, it's economical, and third is it's easy to maintain. The maintenance of this control system is easy, and it is stable. So the disadvantages of open loop control system is it's inaccurate and unreliable, as we have we don't have the out we don't have any feedback system in this. So the output is sometimes, if we are having any external disturbance in the system, in that case the output is incorrect or unreliable, and there'll be internal disturbances since there'll be no feedback. So the output cannot be checked using the sensors whether uh, the disturbance, there is no chance to correct the disturbance, so internal disturbances is there. Recalibration is required from time to time due to external disturbances. So these are the disadvantage of the open loop control system. Next is a closed loop control system. A system in which the control action is dependent on the output is called a closed loop control system. In closed loop control system, the output is continuously monitored and adjusted to the required value by the system. The output signal is fed back and compared to the reference input. So the example of closed loop control system are air conditioning unit, automatic electric irons, voltage stabilizer, DC motor speed control by tachometer, missile launcher system. So let's take an example of temperature control using a room heater. So in closed loop control system, as we know that the output, the control action is dependent upon the output. So in the case of temperature control using a room heater, suppose the desired temperature is that, suppose the temperature currently is 16 degrees Celsius and we want a desired temperature of 22 degrees Celsius. In that case, whenever you turn on your heater, so the thermostat will get turned on and it will heat up the rods till the time the desired temperature is attained. So in the forward path, you can see we have a heater, and at the output we are having the actual temperature of the room, that is 16 degrees Celsius. So the feedback, in the feedback we have a temperature sensor. In order to sense the temperature of the room, that is the current temperature of the room. Suppose we have started with 16 degrees Celsius. So whenever your heater is on, after 2 or 3 minutes, the sensor will take the actual temperature, say it 18 degrees Celsius, and it will feed back that actual temperature to your required temperature, that is 22 degrees Celsius. So the difference between the 18 and 22 is 6 degrees Celsius. So that 6 degrees Celsius will be your actuating signal or error signal that is fed back to the controller, that is the thermostat. So depending upon the temperature, once the 22 degrees Celsius temperature is attained, then the thermostat will be cut out. So whenever the thermostat will cut out, so in that case, the controller will tell the command to the heater to cut out the thermostat, and in that case, the heating will stop for a certain time. So this is how a closed loop control system works. So as I told you, the numerous examples are similarly your air conditioning unit in your house. It's also working on the same temperature. The missile launcher system, the DC motor speed control. In all the cases, we are having a closed loop control system. So the advantage of closed loop and closed loop control system is its accuracy high, since we have a feedback unit and the control action is dependent upon the output. So the accuracy of the system is high. Reduce effect of non-linearities. Due to this feedback unit, we have the external disturbances are reduced with the help of that correcting measures we are having. High bandwidth, facilitates automation. The disadvantages, it's complicated in design and maintenance. It's quite uneconomical since it's costlier. And the problem of stability, it's unstable. The closed loop control system is unstable, as we are having again and again the output is changing in the system. So we can say that closed loop control system is your unstable system. So next is the comparison between the open loop system and closed loop system. In open loop system, the feedback system is absent. There is no feedback in the open loop system. In closed loop system, the feedback system exists. So in that case, we have a sensor in the case as a feedback. So in open loop system, there is no error detector. So we don't have any error detector in order to compare the actual output with the desired output. But in closed loop system, we do have an error detector in order to compare the actual output with the desired output. The open loop system is inaccurate, as I told earlier. It is inaccurate as in whenever we are having an external disturbance in the form of noise or some temperature variations in open loop system, since we don't have any corrective measures, in the form of feedback loop. So there is a constant. So we can, because of that, it will be inaccurate. Plus in closed loop system is accurate because we are having a feedback system, and every time whenever we are checking the actual output, we can compare it with the desired output and the corrective measures can take place. So since the open loop system is inaccurate due to external disturbances, so we can say that they are highly sensitive to parameter changes. So if there will be any parameter changes to temperature or noise or viscosity, so since the corrective measures are not taking place in this case since we don't have any feedback, so these are highly sensitive to parameter changes. Compared to closed loop system, it is less sensitive to parameter changes. Open loop system have small bandwidth. Closed loop system, in comparison to that, having large bandwidth. Now coming to the stability, open loop system is stable system. Since in this case we have an input signal, your open loop control signal, and output signal, the system is stable, as whatever output we are getting, it will be stable. But in closed loop system, the output is changing every time. Every time whenever there will be difference between the actual output and the desired output, again and again the controller will take place, the control action will take place, and again the output is changing. So in that case we can say the closed loop system are unstable. So open loop system is quite economical, since in open loop system we don't have any external any sensing device, we don't have error detector. So less devices are required in order to design an open loop system. So it is highly economical compared to closed loop system. We do have sensors, and sensors are quite expensive, so we can say these are comparatively costlier. So examples of open loop system are coffee maker. So coffee maker, or you can say a system in which for a particular duration, if we set a timer and after that the system is stopped, a time dependent system, or you can say simply, are mostly open loop system. For example, coffee maker. So hair dryer, whether your hair are dry or wet, still the timer, if you turn on, it will keep on giving you hot air till the time you press the stop button. Similarly with the coffee maker. So compared to closed loop system, the example are guided missiles, servo voltage stabilizer, the voltage stabilizer, and all these devices in this control action is depending upon the feedback system. So we can say that these systems are closed loop system. So thank you.